Okay, so here we are doing another addition example, but we are adding a hydrogen halide. So again, start by just drawing everything out chemically. But1-ene is a 4-carbon chain with a double bond on the first carbon. Fill in the hydrogens. Okay, and then we're going to add hydrogen halide. Again, I just like using different colors so I can show you guys where the position of these atoms are going, but it doesn't matter as long as you can see it. Okay, hydrogen chloride is hydrogen HCl. Okay, so what's going to happen here is one of these atoms is going to go to one carbon and the other atom is going to go to the other carbon. So let's again just start by drawing our basic 4-carbon chain and get rid of that double bond. 1, 2, 3, 4. We got 2 here, 1 there, 2, and 3. And then, so we'll put the hydrogen over here, and then we'll put the chlorine right here. And we'll name this guy. We'll go 1, 2, 3, 4. So bute, all single bonds is butane. And we got a chlorine on the second one, so it's 2-chlorobutane. Now, the question you have to ask yourselves is that the only place that the chlorine could go? Well, we put it on the second carbon, but it could also go on the first carbon. And if it goes on the first carbon, then the name changes. Okay, so not only is this a product, we could get this, and we could get a little bit, it's not one or the other. Sometimes they mix and match depending on the conditions. So 1, 2, 3, 4. Again, fill your hydrogens in. Okay, and then in the next product, we could have a hydrogen here, and the chlorine would go on the first carbon. So our name changes to 1-chlorobutane. And we got 2 products, and these, ladies and gentlemen, are called isomers because exactly the same chemical formula, like in terms of chemicals and their composition, but they have different structures, so they do different things. And if that happens, you just need to be mindful of that. So when you are drawing all possible products, really make sure that you focus on, okay, where could the chlorine go? Where could the hydrogen go? Does the name change? So take your time and really think about it. Both of these could exist. Most of the time in a reaction like this, you will have one chemical be more prominent than the other one. So I remember I would do an experiment in university where one of these products would be 70%, the other one would be 30%. And then what's really cool is you can filter the other one out because they have different melting points. Okay, so pretty cool stuff.